Hi guys, welcome to week 2 of distance learning. Today we're going to look into probability, so we're going to extend a little bit on our statistics stuff. So probability is actually one of my favorite things because it's so concrete and actually used in like the real world all around you. You hear a bunch of stuff about probability. So first things first, you need to know some vocab words. So the first vocab word is an action that has a possible outcome, or an action that has possible outcomes. So you're doing something and something else is going to happen. This is what we call an experiment. So just like in science, when you conducting an experiment, something's going to happen. That's what this means by possible outcomes. All right, the result of an experiment. So what are these things that are called after you do a result? After you do an experiment. What is this called? Well, this is called an outcome. So basically, if you roll a dice and it gets on a 6, that's the outcome. So the experiment was rolling a dice. The outcome was I rolled a 6. Okay, so the next one, a list of all the possible outcomes of an experiment written inside of brackets. So this is called a sample space. So, for example, if we would roll a dice, that's the experiment. We're not going to roll it though. So what are the possible outcomes? What could happen? What is the sample space? Well, you could roll a 1, you could roll a 2. So you would write them like this. You could roll a 1, you could roll a 2, you could roll a 3, 4, a 5, or a 6. These are all the things that could happen if you would roll the dice. Right, number 4, a specific outcome or outcomes when an experiment is conducted. So this is what we call an event. Oops. So an event is a specific outcome. So if I asked you, what is the probability that you roll a 6? That 6 is the event that I want to occur. That's the outcome that I want to happen. Right? Blank is the likelihood that an event occurs when an experiment is conducted. So the likelihood, what is the percentage, or how often do you think it's going to happen? This is called the probability. So the probability gives us a number that represents how possible it's going to happen. So what is the probability that we roll a 6? Well, there's only 1 6 out of 6 outcomes. So the probability of it occurring is 1 out of 6 times because there's only 1 6. To find the probability of event, you divide the number of outcomes that satisfy this should say event. So that satisfy the event. So remember, the event is that specific outcome that you want by the total number of outcomes. So that's what I was saying with rolling a dice to get a 6. It's 1 out of 6. So the 6 is that specific event. And when I say 1 out of 6, that's the 1 is the number of outcomes that satisfy the event. So there's only 1 6. Divide by the total number of outcomes, so that would be 1 over 6. Because there's only 1 6, but there's 6 numbers total. Okay, probability can be expressed as a fraction, just like I showed you up here with the 1 6. It can also be expressed as a percentage, or a percent. And if you express it as percentage, it has to be between 0% and 100%. Or it can be expressed as a decimal. And that decimal has to be between 0 and 1. Okay, we can abbreviate the probability of an event by writing the probability of A. So what this means is This P means probability. A is the certain event that you want to look at. So looking back up to this dice problem that we were talking about, if I wanted to know what is the probability of rolling a 6, that's what that means. What is the probability of rolling a 6? You would say, well, it happens 1, because there's only 1 6 on a dice, out of 6 chances, because there's 6 different numbers on a dice. So now, what do we call an event that has a 100% chance of happening? Well, we call that a likely event. Because if it has a 100% chance of happening, that means it's probably going to happen. So for example, say we had a dice, and instead of having 1 through 6 on the dice, say it was a dice that had all 6s on every side. What's the probability of rolling a 6? Well, 100%, because every side has a 6. So on this one, though, it's the opposite, an event with a probability of 0. Well, if say we roll a dice, a normal dice, 1 through 6, and I say, what's the probability of getting a 7? You would say 0%, because there's not a 7 on a dice. So this is what we call an unlikely event. It's not going to happen. All right, going to the back page, we're going to look at some examples now. So a student is chosen at random from a class that has 9 sophomores, 12 juniors, and 3 seniors. So based off of that information, you need to answer these problems A through F. So the first question is, what is the experiment? So what are we actually doing? Well, we're choosing a student at random. That is our experiment. Just choosing a random student. Okay, so what's the sample space? So our sample space means, what are our possible outcomes? Well, we could choose a sophomore. We could choose a junior. Or we could choose a senior. Those are our possible outcomes. That's our sample space. So now we need to find the probability that we choose a sophomore. So remember, this is the event. This is the specific event that we want to find. So P, remember, means probability. So we need to take how many sophomores there are. So there's 9 sophomores. Divide that by how many total there were. So to find out how many total, we have to add up how many students there actually were. So to do that, we're going to do 9 plus 12 plus 3, which is going to give us 24. So there was 24 students total, but only 9 of them were sophomores. So what's the probability of picking a sophomore? Well, it's 9 out of 24. Or I like to put that in percentage. So I'm in my calculator, I divide 9 divided by 24. I'm going to get 0.38. So I'm going to make that 38%. So we only have a 38% of choosing a sophomore. It's likely. So find the probability that we're going to pick a junior. So how many juniors did we have? We have 12 juniors out of 24 total students. Making that a percentage, 50%. So you're more likely to pick a junior than a sophomore, because a junior's 50% chance, 38% chance of picking a sophomore. So now let's look at seniors. Find the probability of picking a senior. Okay, how many seniors were there? There were 3 seniors out of 24 total students. That equals 13% chance. So we have a more chance to pick a junior still. Okay, let's look at the last one. Find the probability to pick a freshman. Okay, how many freshmen do we have? That's not even in our sample space. So can we pick a freshman? No, because there's 0 freshmen out of 24 students total. So that's 0%. This is what we call the unlikely event. It's not going to happen because it's not possible. All right, looking at number 2. A 15-sided dice is rolled. The sides of the die have the numbers 1 through 15 written on them. Okay, so what is the experiment? What are we doing? Well, we're rolling a 15-sided dice. A 15-sided dice. Okay, so what's the sample space? Meaning, what are all the possible outcomes? Well, the possible outcomes are I could roll a 1, a 2, a 3, all the way up to a 15. So those are all the possible things that could happen when we roll this dice. We can get any one of these numbers. So let's find the actual probability of these numbers. So the probability that we roll a 1, well, how many 1s are there? There's only one 1. Out of how many total things? I'm not going to go through and count. I was going to, but I'm not. So there's 15 total options that we could have happen. So that's 1 out of 15, which is 6%. So when you put this in your calculator, you're going to get 0.06. 6%. You only have a 6% chance of rolling a 1. It's crazy, right? Find the probability of rolling a 10. Well, how many 10s are there? There's only one 10. Out of how many total? 15. Well, that's the same as rolling a 1. So 6%. So you have a 6% chance of rolling a 1 or a 10. All right, find the probability that when you roll this dice, you're going to get an even number. So let's go back up to our sample space and count our even numbers. So 2 is even, so that's 1. 4 is even, so that's 2. 3, 4, 5, 6, 7. So we have 7 even numbers out of 15 total numbers. That's going to give us 47% chance. When you roll this dice, you have a 47% chance that you're going to get an even number. So we found even numbers, so let's figure out odd numbers. So how many odd numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Ooh, we have more odd numbers than even numbers. So I'm going to say this is going to be a higher percentage. So 8 out of 15 is going to give me 53% chance. So you have a higher chance of rolling an odd number rather than an even number. It's not that much difference, but you do have a bigger chance because there's one extra odd number. All right, find the probability that the number is greater than 5. So we want greater than 5. Not equal to, but greater than. So we have 6 through 15 that are greater than 5. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers that are greater than 5 out of 15 total. So that's going to give us 67% chance of getting a number bigger than 5. Now this says find the probability that a number is greater than or equal to 5. So that's kind of doing the same thing, except we're adding 5 in. So that's going to be 11 numbers out of 15 total. So that is going to be 73% chance. Right? Find the probability that the number is greater than 2, but less than or equal to 11. So going up here, it has to be greater than 2, so that starts at 3 and goes all the way up to 11 because it has to be less than or equal to 11. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possible chances out of 15 total. And that's going to give us, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I did not count that right. So it's actually 9 out of 15, which is 60% chance of happening. All right, last one for this question. Find the probability that the number is between 1 and 15. Well, that's all of the numbers, right? So there's 15 numbers possible out of 15 numbers total. That's a 100% chance of happening that when you roll this dice, you're going to get a number between 1 and 15. That is the likely. So now we did an unlikely up here and a likely down here. All right, last page. So this is about chance with spinning a wheel. I know it's hard to see on here. If you go back to the PDF file, it should be in color, which is a little bit easier to see. All right, so we want the probability that you roll a 500. So there are two 500s on here. There's one here and there's one here. So we have two chances to get a 500 out of how many total on this wheel. So there's 1, 2, 3, 4, 5, 6, 7, 8 sections on this wheel. So we have 2 out of 8 chances, which reduces to 1/4, which equals 25%. So we have a 25% chance of winning $500. That doesn't seem like a huge chance. So let's find out, what about 1,000? What's the odds of winning 1,000? So if we look at our wheel, there's only 1/1,000. So there's only 1,000 out of 8 possible. So that's only a 13% chance. So we only have a 13% chance of winning $1,000. So we have we're more likely to win 500. All right, probably to lose a turn. So there's 1, 2, 3 lose a turn out of 8 total. That's a 38% chance. You have a 38% chance you're going to lose a turn. All right, probability just to win money. It doesn't matter what the amount is, just what's the probability that you're going to win Monday? So there's money here, 1, 2, 3, 4, 5. There's 5 chances to win money out of 8. That means you have a 63% chance to win money. That's actually a pretty good odds. All right, probability that you will win $100. There's not even $100 on this wheel. So 0 out of 8, which is 0%. So you're unlikely to win that amount. Okay, that's it for the notes, guys. If you have any questions, please reach out to me. The practice is very, very similar to this, where it asks you what this experiment is, what the sample space is, and then what the probability of the outcomes are. So again, if you have any questions, please let me know. I'll see you all on Thursday, that you can ask more questions there in person, and then try and get this to me by Friday. Have a great day.